Hey everyone, I've had a few people ask me to go over the Khan Academy vector word problems. So I just opened up one here. Kader left camp 3 days ago on a journey into the jungle. 3 days of his journey can be described by displacement, direction and distance, vectors d1, d2 and d3. So here they are. d1 is 7, 8, d2 is 6, 2, d3 is 2, 9. Okay, so how far is Kader from camp at the end of day 3? That's in kilometers. And what direction is Kader from camp at the end of day 3? So assume 0 degrees is the rightward direction. Okay, so I've taken a screen capture of these 3 vectors. This really is key to solving this problem. So how far is Kader from camp at the end of day 3? So really what we're talking about is this vector right here. You know what, I probably should have used a different color. So one that's, no, I'll use black. So we're trying to figure out this vector right here. It's kind of like a straight line. I'll try one more. Maybe that's more like it. There we go. So this is called the resultant vector. I'll use an R for this. So the vector R is going to be those 3 vectors added together, d1 plus d2 plus d3. There we go. So in other words, grab those 3 vectors, 7, 8 is the purple one, 6, 2 is the blue one, and 2, 9 is the green one. So when you're adding vectors, just add the x's separately, so 7 plus 6 plus 2, and add the y's separately as well. 8 plus 2 plus 9. So that kind of stuff, I like just throwing it into Wolfram Alpha. Can figure it out for you. There it is. So yeah, if you add all the x's together, you get 15. Add all the y's together, you get 19. So back to the question. So that's this vector here, this black vector. We want to know how far is Kader from camp in kilometers. How far, that's a distance, that's a number. We've got a vector here, but we need the magnitude of the vector. So in other words, magnitude of R, you just use Pythagoras' theory. So 15 squared plus 19 squared, all square rooted. Oh, here we go. Figures it out for me. So the magnitude of R is that, roughly 24 kilometers. So Kader is, we've got to round it to the nearest tenth. So 24.2 kilometers from camp. So we've figured out the length of this vector, this black vector. It's 24.2. The last part is what direction is Kader from camp? So for that, 0 is the rightward direction. So here is, you can think of this as the x-axis, if you like. And we're trying to find this angle here. This is angle theta. So to figure out theta, you just use inverse tan. Inverse tan looks like, oh, you know what, maybe I'll use arctan instead. So the formula is I'll write it here. Its theta is equal to the inverse tan of y over x. So I'm going to use this formula to figure out theta. So inverse tan, that's the same as arctan. So you see a tan quite a lot for that. So y over x, so the y component is 19 and the x component is 15. Oh, nice. OneNote can figure that out too. So it looks like it's, I think this is in degrees. Yeah, it kind of looks like 51 point something degrees. So Keda is at 51. Round your answer to the nearest degree. Yeah, so 52 degrees from camp. So let's shove these answers into here. See if I'm right. So Keda is 24.2 kilometers from camp. That's the magnitude of R. And what direction is Keda? That's the theta value. We use the arctan. Y over x, we get 52 degrees. Oh, nice. Worked out. So I'll do one more. Let's see what this one is. Ooh, this is a nice one. Kana is practicing her golf swing at the driving range. Her first hit can be described by the displacement and direction vector d1, this purple one here. Her second hit, d2. How much further did Kana's second hit go than her first hit? How far are the golf balls apart? So drawing a sketch here is important. Oh, it looks like I don't have purple. I'll just use back then. So, let's see. D1. I'll draw a quick sketch of your X and Y axes. D1, 55.5. 55. Let's say it looks something like this. Let's say this is D1. D1, arrow on top. Next one, 75.10. So let's say something like this. 75.10. This is the next one. D2. So I'll just type in this. Maybe I'll put it here. So D1 is 55.5. D1 equals, alright, and D2 is over here. Here it is. D2 is 75.10. Lowercase d there. Alright. So, okay, how much further did Kana's second hit go than her first? Okay, so how much further? We're talking about distance here. So what we want to do is figure out what's the length of that second hit compared to the length of the first hit. So to do that, basically, how far did first hit go? To work that out, that's the magnitude of d1. So there we just use Pythagoras' theory again. Square root of 55 squared plus 5 squared. Just make this a little bigger. Oh, here it is. Okay, so I'll round that down to, there we go. That's how far the first hit went. That's in meters. How far did the second hit go? That's basically the magnitude of the other vector. That's d2. So square root of 75 plus, so 75 squared plus 10 squared, all square rooted. There we go. 75.6637 kilometers. So how much further did Canna's second hit go than her first? The second hit went this number minus this number. The second hit went roughly 20 meters further. Round your answer to the nearest tenth. So I'll get rid of those digits. There we go, 20.4 meters. How far are the golf balls apart? Okay, so to figure that out, we want to look at this vector here. I'll call this difference. This is my difference vector. So I've got it going from the first hit to the second hit. So to work out what that difference vector is, that difference vector, to go from start to end, you've got to walk along negative d1, then positive d2. So negative d1 plus positive d2. Go from here to here, you walk along minus d1 and then positive d2. That's where the minus sign comes in. So we can work out that difference vector. It's will be negative 55.5 plus 75.10. So again, combine the x's and y's separately. I'm going to shove it into Wolfram alpha. You get the difference vector is equal to 25. So to figure out how far the golf balls are apart, work out the length of this vector. The golf balls are length. So, oh yeah, magnitude, magnitude of diff. The golf balls are the following length apart. I should have said that. Magnitude of the difference vector is square root 20 squared plus 5 squared. Oops, got squared there. There we go. So they're roughly 20 meters apart, round to the nearest tenth. So there it is, 20.6 meters apart. Alright, so let me shove it in here and see if I got the right answer. How much further did Canna's second hit go? 20.4 meters. How far the golf balls apart? Pretty similar number actually. 20.6. Nice. Okay, so I hope that clears up a little bit of the confusion on how to work out the difference of two vectors and also how to add them. Okay, I'll catch you in class.